Not building a race car here, but now we're going to go back and install the head and head gaskets. So as you probably can see, we blew off the top of the engine, degreased it again after we got the carburetor and intake off. Key here is try to keep everything from falling in the engine as you're working. We're going to have the valve cover gaskets off for adjusting the valves. Stuff will fall in there. The intake here. This engine had all kinds of gunk, garbage, and rat's nests and stuff in it. And that's probably why this fuel line was insulated. I'm sure this tractor had problems with vapor lock. It's because it was overheating. I don't know. It's been a long time since all this stuff was pulled off and cleaned up. So as we keep going, we'll keep cleaning. So when you pull the heads off, I just kind of take them apart the same way they kind of go together. Start on the inside and work your way out on the bolts as far as the torque sequence. So to take them off, you can use whatever you want. To put them on, you have to use a torque wrench. I'll try to kind of leave them in there if I can. It's kind of an old habit. Put the same bolts back in the hole they came out of. Not building a race car here, but just kind of an old habit. If I can do it, it's just what I do. Also, sometimes you'll run into some bolts that are longer, so it's also another good reason to keep them in the same hole so you know where they came out. That way the longer bolts go back in the same spot. Bolts should come out easy. Sometimes you'll get some that'll fight you and they will break, so that's why if you're kind of new at it, just recommend using a hand ratchet or one of these on a lower setting. If they feel like they're fighting, just stop and you'll have to work your way out. Often it's a center one that if you're going to have trouble with, because on some models the back threads are open and they get corroded in there. Luckily this one came out nice. Sometimes you might have to whack this with a hammer, other times it'll pop right off. It shouldn't fight you. If it's fighting you, you don't have all the bolts loose. So there's the gasket. And just to show you some more of the stuff that was caked up on the outside of the motor. All this stops it from breathing and cooling. These are air-cooled engines. It's actually an engineered design and cooling system. Everybody thinks you're just air-cooled and they do the thing, but they're not. The air passes through here, underneath, above. There's galleys cut out in the engine block for the air to go. Very important it's all clean. This one doesn't have a ton of carbon on it, but definitely has a little bit. The head actually is pretty clean. If you look at this valve's got a lot of buildup. This one too. Some on the piston head. Here's the gasket that fell off. This is one of the model with the Onans with the fire rings. Some of them have this, some don't. Some guys prefer this, other guys say they don't seal as good. I haven't had any trouble either way. I recommend always using OEM Onan gaskets. The Chinese import ones are nothing like this. They're a really cheap, poor quality graphite material. We don't ever use them, never have, and actually I've never had a tractor come in with them, so it leads me to believe they don't last very long. So always go with an Onan OEM gasket. There, you can debate all day long if you put a new gasket in or reuse it if it's good. They're fairly inexpensive. Most of the time we put new ones in, but if they're in good shape, you can reuse them. You just torque them down a little bit more. You're going to know if you got a problem or not. Obviously, if you reuse it, clean it up good. Well, this is just pretty nasty on this machine. This is dirty in here. That's probably from us just degreasing it. Like I said, this top center one can be troublesome. If it does fight you, get some penetrating oil and just work it back and forth by hand. Back and forth, back and forth. And usually they'll go that way. If not, sometimes they'll snap off and you'll have to drill them and hopefully just clean the threads out or put a thread insert in there. This one fell right off nice too. Again, keep all the bolts in the same place if you can. More carbon on this one for sure. We've seen a lot worse. This one isn't horrible, but a lot worse. There's the gasket. Quick inspection. Gasket looks to be in good shape. This valve definitely full of carbon. This exhaust valve not nearly as much as the other one. This intake has definitely got some. Wouldn't be surprised after we clean this up, if we take a compression reading, it'll be better once you get these valves adjusted and cleaned up. Just keep everything clean as you're working around engines, very important. So what I usually do is bar this flywheel over up here, get your piston all the way down on the cylinder you're looking at. So there's the piston at the bottom of its stroke. Just take a clean rag, just wipe anything out. Not a bunch of oil in there by any means. It looks pretty good. You want to reach in here and feel for any grooves and scratches. And this one actually looks and feels pretty nice. Usually up around here, the top, you'll get some buildup. But this one's actually really pretty good shape and clean. You can rotate the valves and check them out too. Now I'll do the same thing. I'll bar the engine back over. Same deal. No damage on the top of the piston from what we can see. We'll clean that up. The piston doesn't move. Sometimes you'll get some worn slop in there. They call it piston slap, and it'll make a little bit of a knocking noise when it's running. Not the end of the world unless it's real bad, but this one actually looks really nice and tight. So this side looks pretty good. And we'll get it cleaned up and adjust the valves. Same thing on this side. Take a look. No chunks missing out of the valves from what we can see. We'll get them cleaned up though. Notice a lot more buildup on this exhaust valve. Wipe it out. There wasn't much oil on this side at all either. There shouldn't be any in theory, but again, no scoring up and down marks from anything being in there, or dirty air, running without air cleaner, or debris, or carbon. There's no ridge here. It looks pretty good. So now let's start to clean the process. You have to decarbon and clean your heads and valves before you adjust the valves, otherwise you're wasting your time. You can't adjust dirty valves and expect good results. You see all this carbon on here, there's some built up behind it, and the valves are never going to seat right, and you're not going to be able to adjust it. Once you get a couple thousandths of carbon in there, it's going to affect your valve adjustments greatly, and you won't get good sealing. So bring your piston up, top dead center, get your valves there. And there's all different things you can use. A lot of people use oven cleaner, household oven cleaner. You can use different kinds of penetrating oil. Everybody's got their own concoction. I'm going to do that and let that soak. While that's soaking, what I'll usually do is take these bolts and make sure you got them set up on the right way, the head gasket. You can take your head gasket and your head, and again, so just put them back in the right spot where the bolts came out of. And you'll know which ones belong where when you go to reassemble it and retorque it. Not building 5,000 horsepower dragsters here, but it's not a bad practice. You just see, even when we clean this up, all this buildup, the air can't pass through this to cool this head. And it's like this here, it's going to be like this all inside here. Like I said, we blew it out, degreased it, we'll keep cleaning it as we go. But there's no way an air-cooled engine can cool when it's full of grime and grease like that. I'm surprised this engine actually looks as good as it does. This is almost overly cakey and grimy, and I don't understand why, unless there was a hydraulic line that blew all over this motor one time, or some kind of oil spilled and they never got it all cleaned up and it's just been collecting debris. And surprisingly, this head is really clean. It should have more carbon on it compared to what these valves and stuff look like, but this isn't bad at all. Again, we'll do the same thing. Let it soak. Sometimes there's carbon on here, you got to peel it off with a scraper. You get too much carbon built up here. You see this little clearance here, that's what you got from your piston to your top of your head. This gets carbon built up, gets too much, and especially if this thing's overheating, the head's expanding, the piston's expanding, the carbon's expanding, and the piston will come in and smack the carbon, which smacks the top of the head, and you'll break a rod or destroy a head and piston. We've seen it happen quite a few times, so that's why it's important you decarbon these things every 250 to 500 hours and make sure they're running right, they're tuned up right, carburetor's adjusted right, and don't idle them all the way down low. We usually like to keep people idling them around 1500 RPM. If you're idling them down low, they get more carbon buildup and they're running cooler and it's not burning right and they're running richer. So we'll bar it over a little bit, get these valves opened up now. Spray whatever you're using in there. You always want to clean the cylinder every time you're moving this piston up and down. You don't want a little bit of dirt and grime to get in there. You could potentially damage it. Spray down your intake. Again, let these sit. wipe this out right away because you're going to go on the other side and do the same thing. Again, here's our head. This one you can see has got a little bit more buildup than the other side, but definitely not horrible again, but not great. Just let that stuff do its thing. Do the exhaust valve while it's wide open. Okay, so there's a lot of different ways you can clean this. This is how we do them. These are nylon wire bristle brushes. They're a lot less abrasive than using a wire wheel, a metal wheel, or a brass wheel. Remember, the piston's aluminum, the blocks are aluminum on a lot of small engines, and you don't want to gouge them if you can help it. You're not going to destroy the engine if you gouge them a little bit, but what it's going to do is give this carbon a new place to grow and do its thing. If it's smooth, it's got less chance of sticking and will probably burn itself off and not layer up as bad. So use what you got, but use your head. Like I said, these work great. You can use a die grinder or battery cordless one. You can use a hand wire brush, something on the end of a drill. If it's real bad, you got to kind of start with a scraper sometimes, but just be mindful that this is aluminum and just use as little pressure as needed to do the job. You're going to need safety glasses. This is messy and stuff flies. With something like this, you want it on low setting. So everything closed, that's how you start. You want to work in here on the seats, the whole 9 yards. Move it around, get different angles. Got to get all that off of there and out of there. This one, it's really caked on a lot more. This is going to take a little bit more work. You might need a wire brush or might have to get down here and scrape it some more. You can see that right there. That's thick. There's a lot on there. I don't know if you can see how thick that is, but there's a lot there. So the valves are hard. You can use a wire brush or a scraper on the valves because they're hard steel. But again, if you miss, you're going to gouge stuff, so just be careful. There's a lot of stuff coming off there. And that's on the top of this. There's going to be some behind it, just how it goes. So your valve adjustments are going to be off. There's a steel seat in here that's hardened too, but there's aluminum next to it, so be careful. If you wanted, you can lightly do the piston first. Get that stuff right off of there. And then go back to your brush. Alright, that doesn't look too bad. That was pretty easy. And before you do your next step, take some carb clean or brake clean or whatever you want to use. You should have gloves on too. Get everything you just cleaned up off there. Just quick because we're far from done. Not sure if you can see that or not, but right here it says standard STD, and then it's got a date on here. It looks like 3 of 79, so that's probably the original piston in this machine. Standard bore, it's never been bored out. It'll say sometimes 10 or 20 or 30 or 40 thousandths over. Very little movement in there. It's pretty good for being a 40 plus year old machine. And then go until you get one of the valves completely open. So watch the valve, and as soon as the valve starts closing right there, bring it back a little bit, and then that valve's open. Now you want to try to get behind this as good as you can too, but put some more of your cleaner on there, whatever you're using, and then work it. Be mindful, this is metal. This will hit your aluminum and scratch it and gouge it too, so you can take this and give it a spin as you work around it. Usually turn it quarter turn, you do a few times. And important to get your seat in here too. I don't know if you can see the seat, but it's cleaning up nice. And then sometimes the shaft will have some carbon. You can get in here with an O-ring pick or a screwdriver and knock big chunks off. Get your brake clean or carb clean. At this point you can come in from the top too and then force all this stuff out a little bit. And then work around till you get your next valve up. Spray some more of your cleaner that you're using on there. You'll Notice we left the muffler intact and didn't mess with taking the exhaust off. 9 times out of 10 we don't bother taking the exhaust off. You don't have to unless you have an exhaust leak. You need to replace the exhaust gasket or a loose or broken bolt. So again, wipe this out before you bar it over again. And bring this back up to the top. And then take your wire brush, whatever you're using, and be real careful. Now this is your gasket mating surface, and the head gaskets are a hard material, they're not soft. So you don't want to gouge or do anything here, you just want to get it clean so everything mates up nice. Again, you're going to want to get all this out of here. This isn't your mating surface, so you can use a scraper here if you want. This is outside the head. Again, just get everything nice and clean. Very important. Alright, that part's done. This one was not bad. Like I said, we've run into them where they're horrible. Horrible, horrible, horrible. Caked on, probably 1/16 to 1/8 thick. And actually broken rods from impact. It affects the way the engine runs, affects the way it cools, power, efficiency, burns more fuel. Alright, so next we got the head. So the head, get all this stuff out of here. This is fine to use a scraper because your sealing surface is only this raised ridge. Alright, so the head, same deal. It's aluminum. You don't want to over clean it. Use as little pressure as you need to get the job done. Same deal, these are nylon. It's different design. It works good to get up in where the spark plug hole is and some other spots where the wire wheel won't go in, or the round rotary wheel. Again, with your brake clean or carb clean or whatever you got in your magic bottle. Real important to have this combustion chamber clean, as smooth as you can. I mean, if you want to sit here and polish and play around, it's up to you. And be as picky as you want to be. So that's pretty good for now for that. Just take your wheel and do your mating surface now for the gasket. So you'll see some moisture coming off the wheel, and also these wheels do wear down, so that's what you kind of see flying out of there. It's not chunks of aluminum, don't worry. Do the same thing on the other side. So now we're going to go back and install the head and head gaskets. Nothing real technical here, real hard. The important thing is to follow the torque procedure, the sequence of the bolts, and the proper torque pounds. There's the heads, all clean. Now they're actually going to function and cool and flow. All the carbon's gone, everything's smooth, no gouges. So you're going to take your new gasket, make sure you got it going the right direction. The intake valve is the bigger one, but line your holes up. And what I always do is I'll start and grab 2 bolts. We already cleaned the bolts, sprayed them down, they're dry. The holes we sprayed out, they're dry. You want to torque everything dry. And I put at least 2 bolts in the head with the head gasket. So get your head lined up, your holes lined up in the back. Make sure these are always going through. Otherwise your head gasket will slip, will drop behind, get misaligned. People have actually dropped them to not even know it and find them on the floor after they get the bolts in there. So putting 2 bolts in there keeps that from happening. Got this one and this one started. Got a couple in there. Make sure this is up against the head flat. This piece of metal here isn't stopping you. Look around behind, feel, and then grab your rack of head bolts and start putting them in where they belong. So the proper sequence when you go to torque with the torque wrench is 1, 2, 3, 4, 5, 6, 7, 8, 9. Never put these in with an air tool or a cordless tool. Always get them started by hand. They should go very smooth, very easy. And then just get them just seated slightly with your ratchet and try to stick to the torque sequence when you're doing this. It's not as imperative until you start torquing them down, but you work from the center out and up. Just barely grabbing. Make sure you got all the washers on these. Washers are important for the torquing. Okay, now that they're all just basically seated in there, very light, not much torque. Your torque wrench, And the torque values from the specs for the manual are 16 to 18 pounds. Remember, your bolts are steel, your head and your block are aluminum, and the threads will pull out, so you want to be careful on how much you torque them. If you're reusing your head gasket, your engine's been taken apart on and off the head and the bolts and stuff, the threads stretch and wear. We usually go a little bit higher than what the factory recommends. You can kind of gauge it by feel and experience, but if you're new to this, then 18 pounds is probably good. Push it to 20 if you want. That's probably where you should stay. And the right way to do this is, they say, go 5 pounds on all the holes in the right sequence, 10 pounds on all the holes in the right sequence, and then your final torque. For video purposes, we're not going to do that for time savings, but we'll go to 10 and we'll go to final torque just to show you how. If you can see that, here's the torque wrench, but here's your foot-pounds on this side, and you're going to use foot-pounds. Then it goes 10, 15, 20, 25. It alternates. As you spin this down here, these are increments of 1 all the way around is up to 5 pounds. As it spins, wherever this is going on the horizontal line, that's where you're at. So the patterns are a little different on the heads. Pay attention to which head's yours. You can tell by the cutout here. So the first one on this side is going to be right here. We're set at 10 pounds. You can never use the torque wrench. It'll have a light click, a light break when you hit that 10 pounds. If you hear that, I don't know if you can hear that and see that. That's 10 pounds. Go to the next one, do the same thing. You hear that right there. And this is the next one you want to go to up here is number 3. There's your brake. Number 4. There's your brake. You see it, hear it. And 9. You can feel it, you can hear it. Okay, go back to your torque wrench now. And this would be your third and final step. We did skip the initial step for the video. And you bring this up to 20 or 18 pounds, somewhere in there. Got to look at that, but here's the 20 pound mark. There's the horizontal line. There's the 0 lined up. If you wanted 22, then the 2 would be lined up. Alright, again, follow the pattern. Here's number 1. There we go. Number 2. There we go. Number 3. There we go. Number 4. So you're all set. It's torque to spec. Go do the other side.